All right. All right. Let's get this show on the road. Okay. All right. Let's let some people roll up in here. Yeah. Okay, stop yawning. Oh boy. Come on. Wake up, wake up. Let's let some people roll up in here. We'll get started here shortly. We're going to be reading some C programming today, diving into C, getting this going. So I hope you guys are enjoying today. Let's go ahead and get into this. All right, let me grab a little drink and then we'll get started. All right. Hey, Beatrice, how's it going? Hey, Michael, let's code. My time to learn C has come. Yeah, we're getting into it today. Appreciate you for joining me again, once again. Welcome, you've been here for quite a while. One of the OGs on the channel. Welcome back in. Yeah, we're going to be diving into C, getting into more lower level programming languages and computer science information. So this is really going to be the start of kind of diving past our beginner level more into the intermediates and really trying to figure things out. So, all right, you guys, let's go ahead and get started without further ado. I'm going to be recording this one, so bear with me as I do kind of like an introduction here so I can, we're going to be reading this one live on the stream here, or on the channel here, so. All right, let's go ahead and make sure we got the Twitch going. All right, Twitch is going. And let's start the recording. Okay. C programming, a modern approach. Second. All right. and then we'll go here. We'll initialize a repo here. And we'll go .git ignore, add this, git add. First commit starting chapter 1. Okay, and then let's go to GitHub. Let's go new repository, C programming, a modern approach. Okay. Public entity. Right. Copy this here. Why is my internet so slow? Hey, Hall Minotaur, embedded languages for the win. Yeah, we're going to be hopefully getting past some Python here and getting some understanding. Not only, so I'm not going to be abandoning Python at all. We're going to be probably still primarily coding in Python, as you know, modern languages have developed lots of tools and packages for us to be able to quickly code up some of our projects, more data science and science STEM related projects faster than normal. Um, what's going on here? Why is this taking so long? Okay, so now let me go here. Let me add a remote origin. Okay, already exists. Let me just push this up. Get push setup stream. What is going on here? It's not my internet. Let me restart. What is going on? The GitHub server's down right now? A bootstrap repo to rollout project? What is it? Oh, it's this guy. What's going on here? Remove PDF size issue. We'll set up stream. What? Yeah. Come on. What's going on? Nothing should be so big that it's taking forever here. It's trying to still add this. I thought I deleted it though. All right. Let's remove what's cached then. And then let's push this. It wants us to do push origin name. This is ridiculous. All right, we're gonna delete. This is so ridiculous. Why is this taking forever? Ugh, I untracked it. Why? I just want to read the book. Come on. No, just remove all PDF files. I don't want to install anything. No filter repo. Okay, I'm done with this. Okay. It's gonna be annoying with me, then I want to be annoying too. I'll be annoying too. Goodbye. I'll be annoying. C, programming a modern approach. Could have been like halfway done with the chapter by now. This is so annoying. C programming a modern approach. Okay. All right. Jeez, what a mess. Garbage. Okay. Okay, cool. All right, repo initialized. Holy crap. Are you using Linux? No, dude. It's pretty easy to tell here that we're on Mac, my boy. All right, here we go. Welcome in. Hey, Jose, how's it going? All right, that was a disaster. Finally. Wow. Okay, here we go. Let's go. Okay. All right. All right, welcome back, everybody. I hope you're having a wonderful day so far. My name is Michael. Today we're going to be jumping back into some more reading, but we're going to be diving into some lower level programming languages, more specifically that of C. Today we're going to be learning more about C and starting our journey into programming more in C. We're going to be reading C Programming, A Modern Approach, second edition by K.N. King. This is a great book for learning C programming, having some examples to help you learn, and providing all the necessary information regarding beginner level C and hopefully into intermediate levels. All right. Let's go ahead and get into chapter 1 here. All right, this is going to be chapter 1, introducing C. This is going to be the audiobook style for the channel. If you guys enjoyed, please subscribe and like, and I'll see you guys in the next one. Thanks so much for being here. Okay. Chapter 1, introducing C. When someone says, I want a programming language in which I need to say what I wish I'd done, give him a lollipop. What is C? The simple answer, a widely used programming language developed by, oh my gosh. What is C? The simple answer, a widely used programming language developed in the early 1970s at Bell Laboratories. Conveys little of C's special flavor. Before we become immense... Oh my gosh, dude, this is off to a rough start already. Okay, I gotta relax. All right, introducing C. What is C? The simple answer, a widely used programming language developed in the early 1970s at Bell Laboratories. Conveys little of C's special flavor. Before we become immersed in the details of the language, let's take a look at where C came from, what it was designed for, and how it has changed over the years. Section 1.1. We'll also discuss C's strengths and weaknesses and see how to get the most out of the language. Section 1.2. Section 1.1, History of C. Let's take a quick look at C's history from its origins to its coming of age as a standard language to its influence on recent languages. Origins. C is a byproduct of the Unix operating system, which was developed at which was developed at Bell Laboratories by Ken Thompson, Dennis Ritchie, and others. Thompson single-handedly wrote the original version of Unix, which ran on the DEC PDP-7 computer, an early mini-computer with only 8K words of main memory. This was 1969 after all. Like other operating systems of the time, Unix was written in assembly language. Programs written in assembly language are usually painful to debug and hard to enhance. Unix was no exception. Thompson decided that a higher level language was needed for the further development of Unix, so he designed a small language named B. Thompson based B on BCPL, a systems programming language developed in the mid 1960s. BCPL in turn traces its ancestry to ALGOL 60, one of the earliest and most influential programming languages. Ritchie soon joined the Unix project and began programming in B. In 1970, Bell Labs acquired the PDP-11 for the Unix project. Once B was up and running, the PDP-11, Thompson rewrote a portion of Unix in B. By 1971, it became apparent that B was not well suited to the PDP-11 computer, so Ritchie began to develop an extended version of B. He called his language NB or New B at first, and then as it began to diverge more from B, he changed the name to C. The language was stable enough by 1973 that Unix could be written in C. The switch to C provided an important benefit: portability. By writing C compilers for other computers at Bell Labs, the team could get Unix running on those machines as well. Standardization. C continued to evolve during the 1970s, especially between 1977 and 1979. It was during this period that the first book on C appeared, the C programming language, written by Brian Kernighan and Dennis Ritchie and published in 1978, quickly became the Bible of C programmers. In the absence of an official standard for C, this book, known as K&R or the White Book to... Oh my gosh. What is this word? Pronounce. Aficionados. What the heck? Aficionados served as a de facto standard. During the 1970s, there were relatively few C programmers, and most of them were Unix users. By the 1980s, however, C had expanded beyond the narrow confines of the Unix world. C compilers became available on a variety of machines running under different operating systems. In particular, C began to establish itself on the fast-growing IBM PC platform. Hey, Lance. With C's increasing popularity came problems. Programmers who wrote new C compilers relied on K&R as a reference. Unfortunately, K&R was fuzzy about some language features, so compilers often treated these features differently. Also, K&R failed to make a clear distinction between which features belonged to C and which were part of Unix. To make matters worse, C continued to change after K&R was published, with new features being added and a few older features removed. The need for a thorough, precise, and up-to-date description of the language soon became apparent. Without such a standard, numerous dialects would have arisen, threatening the portability of C programs, one of the language's major strengths. The development of a U.S. standard for C began in 1983 under the auspice of the American National Standard Institute, or ANSI. After many revisions, the standard was completed in 1988 and formally approved in December of 1989 as ANSI Standard X3.159-1989. In 1990, it was approved by the International Organization for Standardization as International Standard ISO/IEC as International Standard ISO/IEC IEC 9899, 1990. This version of the language is usually referred to as C89 or C90 to distinguish it from the original version of C, often called KNRC. Appendix C summarizes the major differences between C89 and KNRC. The language underwent a few changes in 1995, described in a document known as Amendment 1. More significant changes occurred with the publication of a new standard, ISO/IEC 9899, 1999, in 1999. The language described in the standard is commonly known as C99. The terms ANSI or ANSI-C, ANSI ISO-C, and ISO-C, once used to describe C89, are now ambiguous thanks to the existence of the two standards. Because C99 isn't yet universal, and because of the need to maintain millions, if not billions, of lines of code written in older versions of C, I'll use a special icon shown in the left margin to mark discussions of features that were added in C99. A compiler that doesn't recognize these features isn't C99 compliant. If history is any guide, it will be some years before all C9. If history is any guide, it will become some years. If history is any guide, it will be some years before all C compilers are C99 compliant, if they ever are. Appendix B lists the major differences between C99 and C89. C-based languages. C has had a huge influence on modern-day programming languages, many of which borrow heavily from it. Of the many C-based languages, several are especially prominent. C++ includes all the features of C but adds classes and other features to support object-oriented programming. Java is based on C++ and therefore inherits many C features. C# is a more recent language derived from C++ and Java. And Perl was originally a fairly simple scripting language. Over time, it has grown and adopted many of the features of C. Considering the popularity of these newer languages, it's logical to ask whether it's worth the trouble to learn C. I think it is for several reasons. First, learning C can give you greater insight into features of C++, Java, C#, Perl, and other C-based languages. Programmers who learn one of these languages first often fail to master basic features that were inherited from C. Second, there are a lot of older programs around. You may find yourself needing to read and maintain this code. Third, C is still widely used for developing new software, especially in situations where memory or processing power is limited to where Third, C is still widely used for developing new software, especially in situations where memory or processing power is limited or where the simplicity of C is desired. If you haven't already used one of the newer C-based languages, you'll find that this book is excellent preparation for learning these languages. It emphasizes data abstraction, information hiding, and other principles that play a large role in object-oriented programming. C++ includes all of the features of C, so you may be able to use everything you learn from this book if you later tackle C++. Many of the features of C can be found in other C-based languages as well. 1.2 Strengths and weaknesses of C. Like any other programming language, C has strengths and weaknesses. Both stem from the language's original use, writing operating systems and other systems software, and its underlying philosophy. C is a low-level language. To serve as a suitable language for systems programming, C provides access to machine-level concepts, bytes, and addresses, for example, that other programming languages try to hide. C also provides operations that correspond closely to a computer's built-in instructions so that programs can be fast. Since application programs rely on it for input-output, storage management, and numerous other services, an operating system cannot afford to be slow. C is a small language. C provides a more limited set of features than many languages. The reference manual of the second edition of KNR covers the entire language in 49 pages. To keep the number of features small, C relies heavily on a library of standard functions. A function similar to what other programming languages might call a procedure, subroutine, or method. C is a permissive language. C assumes that you know what you're doing, so it allows you a wider degree of latitude than many languages. Moreover, C does not mandate the detailed error checking found in other languages. Strengths. C's strengths help explain why the language has become so popular. Efficiency. Efficiency has been one of C's advantages from the beginning. Because C was intended for applications where assembly language had traditionally been used, it was crucial that C programs could run quickly and in limited amounts of memory. Portability. Although program portability wasn't a primary goal of C, it has turned out to be one of the language's strengths. When a program must run on computers ranging from PCs to supercomputers, is often written in C. One reason for the portability of C programs is that, thanks to C's early association with Unix and the later ANSI ISO standards, the language hasn't splintered into incompatible dialects. Another is that C compilers are small and easily written, which has helped make them widely available. Finally, C itself has features that support portability, although there's nothing to prevent programmers from writing non-portable programs. Power. C's large collection of data types and operators help make it a powerful language. In C, it's often possible to accomplish quite a bit with just a few lines of code. Flexibility. Although C was originally designed for systems programming, it has no inherent restrictions that limit it to this arena. C is now used for applications of all kinds, from embedded systems to commercial data processing. Moreover, C imposes very few restrictions on the use of its features. Operations that would be illegal in other languages are often permitted in C. For example, C allows a character to be added to an integer value, or for that matter, a floating point number. This flexibility can make programming easier, although it may allow some bugs to slip through. Standard library. One of C's great strengths is its standard library, which contains hundreds of functions for input, output, string handling, storage allocation, and other useful operations. Integration with Unix. C is particularly powerful in combination with Unix, including the popular variant known as Linux. In fact, some Unix tools assume that the user knows C. Weaknesses. C's weaknesses arise from the same source as many of its strengths. C's closeness to the machine. Here are a few of C's most notorious problems. C programs can be error-prone. C's flexibility make it an error-prone language. Programming mistakes that would be caught in many other languages can't be detected by a C compiler. In this respect, C is a lot like assembly language, where most errors aren't detected until the program is run. To make matters worse, C contains a number of pitfalls for the unwary. In later chapters, we'll see how an extra semicolon can create an infinite loop where a missing and symbol can cause a program crash. C programs can be difficult to understand. Although C is a small language by most measures, it has a number of features that aren't found in all programming languages and that consequently are often misunderstood. These features can be combined in a great variety of ways, many of which, although obvious to the original author of a program, can be hard for others to understand. Another problem is the terse nature of C programs. C was designed at a time when interactive communication with computers was tedious at best. As a result, C was purposefully kept terse to minimize the time required to enter and edit programs. C's flexibility can also be a negative factor. Programmers who are too clever for their own good can make programs almost impossible to understand. C programs can be difficult to modify. Large programs written in C can be hard to change if they haven't been designed with maintenance in mind. Modern programming languages usually provide features such as classes and packages that support the division of a larger program into more manageable pieces. C, unfortunately, lacks such features. Obfuscated C. Even C's most ardent admirers admit that the code can be hard to read. The annual International Obfuscated C Code Contest actually encourages contestants to write the most confusing C programs possible. The winners are truly baffling, as 1990's Best Small Program shows this. Wow. This program, written by Doron Ozvalansky and Baruch Nissenbaum, prints all solutions to the 8 queens problem. the problem of placing 8 queens on a chessboard in such a way that no queen attacks any other queen. In fact, it works for any number of queens between 4 and 99. For more winning programs, visit www.ioccc.org, the contest's website. Effect of use of C. When C effectively requires taking advantage of C's strengths while avoiding its weaknesses, here are a few suggestions. Force of Nature, this book seems good. Going to check it out for myself. Yeah, I've got a link to it in my Discord if you want to check it out, as well as I'm going to be taking notes on my GitHub repo. So it's all going to be live here on the stream and channel as we read through it. Thanks for coming in, Nature. Effective use of C. Using C effectively requires taking advantage of C's strengths while avoiding its weaknesses. Here are a few suggestions. Learn how to avoid C pitfalls. Hints for avoiding pitfalls are scattered throughout this book. Just look for this warning symbol for a more extensive list of pitfalls. See Andrew Koenig's C Traps and Pitfalls. Modern compilers will detect common pitfalls and issue warnings, but no compiler spots them all. Use software tools to make programs more reliable. C programmers are prolific tool builders and users. One of the most famous C tools is named lint. Lint, which is traditionally provided with Unix, can subject a program to a more extensive error analysis than most C compilers. If lint or a similar program is available, it's a good idea to use it. Another useful tool is a debugger. Because of the nature of C, many bugs can't be detected by a C compiler. These show up instead in the form of runtime errors or incorrect output. Consequently, using a good debugger is practically mandatory for C programmers. Take advantage of existing libraries. One of the benefits of using C is that so many other people also use it. It's a good bet that they've written code you can employ in your own programs. C code is often bundled into many libraries, contain collections of functions, obtaining a suite. Take advantage of existing code libraries. One of the benefits of using C is that so many other One of the benefits of using C is that so many other people also use it. It's a good bet that they've written code you can employ in your own programs. C code is often bundled into libraries, collections of functions. Obtaining a suitable library is a good way to reduce errors and save considerable programming effort. Libraries for common tasks include user interface development, graphics, communications, database management, and networking are readily available. Some libraries are in the public domain, some are open source, and some are sold commercially. Adopt a sensible set of coding conventions. A coding convention is a style rule that a programmer has decided to adopt even though it's not enforced by the language. Well-chosen conventions help make programmers more informed, easier to read. Well-chosen conventions help make programs more uniform, easier to read, and easier to modify. Conventions are important when using any programming language, but especially so with C. As noted above, C's highly flexible nature makes it possible for programmers to write code that is all but unreadable. The programming examples in this book follow one set of conventions, but there are other equally valid conventions in use. We'll discuss some of the alternatives from time to time. Which set you use is less important when adopting some conventions and sticking to them. Avoid tricks and overly complex code. C encourages programming tricks. There are usually several ways to accomplish a given task in C. Programmers are often tempted to choose the method that's most concise. Don't get carried away. The shortest solution is often the hardest to comprehend. In this book, I'll illustrate a style that's reasonably concise but is still understandable. Hey Tim, nice book. Yeah, I like this book so far. It's got some good. I like how it's like getting you kind of like leading you in, warming you up. It's taking you out to dinner first, right? Uh, Stick to the standard. Most C compilers provide languages. Stick to the standard. Most C compilers provide language features and library functions that aren't part of the C89 or C99 standards. For portability, it's best to avoid using non-standard features and libraries unless they're absolutely necessary. Okay, so I'll go back through at the end of the chapter and we'll go ahead and fill in some notes here. It's kind of more just like background stuff, so it's kind of we can keep moving. So what is this Q&A section anyway? Glad you asked. The Q&A section, which appears at the end of the chapter, serves several purposes. The primary purpose of Q&A is to tackle questions that are frequently asked by students learning C. Readers can participate in a dialogue more or less with the author, much of the same as if they were attending one of my classes. Another purpose of a Q&A is to provide additional information about topics covered in the chapter. Readers of this book will likely have widely varying backgrounds. Some will be experienced in other programming languages, whereas others will be learning to program for the first time. Readers with experience in a variety of languages may be satisfied with a brief explanation and a couple of examples, but readers with less experience may need more. The bottom line, if you find the coverage of a topic to be sketchy, check Q&A for more details. On occasion, Q&A will discuss common differences among C compilers. For example, we'll cover some frequently used but non-standard features that are provided by particular compilers. So, question, what does lint do? Lint checks a C program for a host of potential errors, including but not limited to suspicious combinations of types, unused variables, unreachable code, and unportable code. It produces a list of diagnostic messages, which the programmer must then sift through. The advantages of using lint is that it can detect errors that are missing by the compiler. On the other hand, you've got to remember to use lint. It's all too easy to forget about it. Worse still, lint can produce messages by the hundreds, of which only a fraction refer to actually errors. Where did lint get its name? Unlike the names of many other Unix tools, lint isn't an acronym. It got its name from the way it picks up pieces of fluff from a program. How do I get a copy of lint? Lint is a standard Unix utility. If you rely on another operating system, then you probably don't have lint. Fortunately, versions of lint are available from third parties. An enhanced version of lint known as Splint, secure programming lint, is included in many Linux distributions and can be downloaded for free from splint.org. Is there some way to force a compiler to do more a more thorough job of error checking without having to use lint? Yes, most compilers will do more thorough check of a program if asked to. In addition to checking for errors, undisputed violations of the rules of C, most compilers also produce warning messages indicating potential trouble spots. Some compilers have more than one warning level. Selecting a higher level causes the compiler to check for more problems than choosing a lower level. If your compiler supports warning levels, it's a good idea to select the highest level, causing the compiler to perform the most thorough job of checking that it's capable of. Error checking options for the GCC compiler, which is distributed with Linux, are discussed in the Q&A section at the end of Chapter 2. I'm interested in making my program reliable as possible. Are there any other tools available besides lint and debuggers? Yes, other common tools include bounds checkers and leak finders. C doesn't require that array subscripts be checked. A bounds checker adds that capability. A leak finder helps locate memory leaks, blocks of memory that are dynamically allocated but never deallocated. Cool. Starred questions cover material too advanced or too esoteric to interest the average reader. Hey, Link, thanks so much for the follow on Twitch. You're awesome, my boy. Woohoo! Thanks for coming in. Appreciate you so much for coming in. Curious readers with a fair bit of programming experience may wish to delve into these questions immediately. Others should definitely skip them on the first reading. Interesting. All right, cool. That was chapter 1. That was a quick little chapter, not too bad. Just going over some of the history of C and some of the strengths and weaknesses of C. So it just talked about how C was developed by this, Bell Laboratories by Ken Thompson, Dennis Ritchie, and some others. Originally, on this computer under Unix, and then was expanded out over time as features were added and more and more computers started to advance. Thank you for the follow, Kitty Sushi. I appreciate you so much for the follow on, let's see, was that on YouTube? No, it was on Twitch. Thank you so much, Kitty. You're awesome. I like that name, Kitty Sushi. That's a cool name. Right, so as these computers got better, it looks like the languages got more features to evolve and eventually transition into new B and then eventually into C. And then we had some standardization take place. So C, it seems like one of the drawing points of C is that it was standardized by like a group of people or an industry, and so that the programs that are in C and in the future programs have portability access. Like it's really easy because of the standardization to kind of take your programs in C and run them, import them, and compile them on different machines, as my assumption, because everyone's kind of following these kind of standardization practices for how the code should be written and what should be like done with it. Um, so that was a pretty cool little tidbit of information, right? Because C compiles down into executables, whereas like not like Python, where is in Python files that are interpreted, and then you could use like packages or things to package your code up into an executable in Python, whereas C just directly compiles down to an executable, from what I'm understanding. All right. Cool. And then we got into C-based languages, where it kind of talked about how some other future languages, C++, obviously Java, C Sharp, Perl, Python, are based off of C, and add in some additional features like object-oriented programming, and functionality, and different types of packages and libraries and whatnot. But they all kind of base off of the main core of C, it looks like, right? So we got into some strengths and weaknesses of C, right? How C is a low-level language and it's relatively small and permissive. So now these are I'm not sure if these are kind of more like facts. Like it's like a low level. It can be interact with a computer. It's small, so it's pretty easy to learn, but it's pretty robust, and it's a permissive language. It allows you to really manipulate the computer as you see fit. Now, strengths and weaknesses here, right? We talked about how it's fast, it's efficient, it's portable, but also its weaknesses because it doesn't have a lot of error checking. It's mainly user dependent. If you have errors, they're kind of your fault, right? As most errors are. It can be hard to understand just because it's not as like English based as like Python is, and can be difficult to modify because we're not packaging up this code in like objects and in different types of things. I haven't actually written many projects in C at all, so I'm really curious to see how this one impacts me going into the future. Because right now I kind of set up all my projects in object-oriented, configurations with, objects as Python classes for various things that I want to do, and assigned methods for repeated functionality for those things. And so it's going to be interesting going into C now to see, okay, how can we design our code to be more fluent without the use of object-oriented programming, and how can we create, write C programs to um, avoid that pitfall. But then I think that'll help us in the future to write more cleaner object oriented code because we now know how to avoid pitfalls of having code without object orientation. So I'm kind of excited to get into this feature because I want to write more code that is, you know, see what it would take to write code that isn't as object oriented. Right, it just talks about how again how C can be a little bit difficult to read as this program. This is an actual working script that solves the eight queens problem, but this is pretty cryptic, and even myself looking at this now, I don't even want to try. So, um, and then we got into the Q&A, right? Those effective uses of Q&A. It has the Q&A sections and some like kind of facts here for the effective uses of C. So this was chapter 1 of. All right, this was chapter 1 of K.N. King's C Programming, a Modern Approach, second edition. I really hope you enjoyed this chapter. I'm going to go back through and update my notes here with some stuff so you can get access to these on my GitHub if you would like. Thanks so much for reading and joining along with me for chapter 1. I will see you guys in the next one. All right, that is the end of the recording there. Sweet. Okay, so let's go back through and update some of our notes here. Unlink says that's one of the reasons why there are so many C compilers out there. Sorry, could you specify why is I'm not it's probably something I was reading about, but is it why is there there's so many C compilers, C being an ISO standard. Okay, so let's get some notes before we call it for today. Let's kind of fill out our notes for these sections. Yes, we're getting into some C here for Middle of Thunder. We're finally starting to dive down into more lower level languages. We did get some C introduction into in our CS50X course, but We didn't really take that so seriously as we were mainly focusing on Python and stuff. And this will be a good, second pass through some C beginning lessons to reinforce those topics and hopefully solidify them so we can start building some projects and writing some scripts in C potentially. I would like to maybe get like a microcontroller, like an Arduino or a Raspberry Pi, and maybe set up like some sort of like at-home garden automation. I think would be kind of cool. I've been wanting to get into like growing some like vegetables and having like maybe some flowers and stuff in whether it be on my balcony or in my closet or something. And I think it would be kind of cool to set up like a little microcontroller to control like a light and fans and like create like an automated, um, like a greenhouse. So I really think that would be cool. We could add in some like sensors for like humidity and have like the fans automatically kick on when certain humidity levels are like reached or something like that. I don't know. It'd be kind of really cool, I think, to kind of incorporate our programming into more hardware based and kind of like actual building some cool like product things, so physical products. So let me know what you guys think about that. I'm going to be trying to dive into that here on the channel here and seeing if we can really build something kind of cool. um, are you fully finished with Python? No, definitely not. We're going to keep going in Python. This is going to be just to further increase our skills in Python. I often think to myself, why is this happening in Python? And I don't know why, because I don't know C. So I would like to know C and become more fluent in C so I can better understand what's actually going on in these more abstracted languages, and so I can just become a better computer scientist, really. That's the goal. Um, well, I really enjoyed my previous uni program course that involved the use of Python. Therefore, I rolled in another programming course, this time Java, making a game and a bit of Python. That sounds pretty fun. Yeah, right. Get a terrarium with 10 frogs. Okay, so let's go over some history of C really quickly. Let's get some notes here. Um, so C is a product of the Unix operating system. C is a product of the Unix operating system. So this is going to be a good opportunity for us to really understand what these things are, because I've often come across a lot in the studying like, oh, the Unix Linux operating system, the this, the that, and I actually don't really know what these are because I've never had any like direct experience like looking them up. Like I've kind of just taken things at face value growing up. Oh, the computer has Windows on it. That's what I know. Like I never really cared to look deeper and to figure out why these things come the way they are and what actually is running on them. So I'm very curious about that. So I'm going to do Unix here. So let's look up what is the Unix operating system. So C is a product of the Unix operating, which is developed by Bell Laboratories by Ken Thompson and other. Thompson single-handedly wrote the original version of Unix, which ran. Okay, so Unix operating system. The Unix operating system is a multi-user, multitasking operating system originally developed in late 1960s and early 1970s at AT&T's Bell Labs by Ken Thompson, Dennis Ritchie, and others. Okay, so it's just an operating system, right? Developed by AT&T's Bell Laboratories. Okay, so then is there any like it became one of the most influential operating systems in computing history because of the design principles, which emphasize simplicity and modularity. Each program or utility does one thing well, and these small programs can be combined using pipes and shell scripts to perform complex tasks. Okay, so programs can be combined using pipes and shell scripts to perform complex tasks. Portability. It was written in C programming language, which makes it easy to adopt hardware, right? So this was written in C. Multi-user and multitasking. Multiple users can run multiple processes simultaneously. Okay. Hierarchical file structure. All devices and files are represented in a single file-like directory structure. Okay. Security and permissions. Access to files and processes controlled through user and group permissions. So this was kind of like one of the first modern operating systems that we currently see today, like where you have users and admin access. You have like file systems and like the recursive file tree nature. You have multi-user multitasking, right? You have so okay, so modern operating systems like Linux, Mac OS, and even parts of Android and iOS are Unix-like, meaning they follow Unix principles or are derived from it. In fact, Mac OS is Unix certified, while Linux is not derived directly from Unix but re-implements its design from scratch. Okay, got you. So, in other words, Unix is just like an operating system like Mac OS or Windows, but it was just from back in the day on earlier computers that was kind of like the grandfather for modern operating system design for users and file access through like the recursive like tree structure, group permissions, pipes and shell scripts for performing multiple tasks and more complex scripting, and things like that. So it's just kind of a precursor to all these other systems. Exactly, it's a perfect summary. In other words, Unix was the blueprint for how modern operating systems are designed and organized. Before the Unix, most systems were clunky, single purpose, and hardware specific. Unix introduced the idea you could have many users on one system. Each user could run multiple processes at once. Everything, files, devices, even running processes could be treated consistently file-like way. The system should be composable, so small tools could be linked together. And the OS is written in high-level language C, not assembly, so it could be portable across different machines. So it's C, which makes it portable to different machines. So yes, OS, Mac OS, Linux, and even Android all carry Unix DNA. Windows took a different path historically, but it's adopted many similar concepts over time. Cool. Let's get caught up on some chats here. We got a lot of chats. People are liking this topic. Um, hold up. Oh crap! The Twitch chats are hard because I can't scroll back. I'm talking about Y2K. Okay, cool. I think we're good. People are just chatting about stuff. Hey Pluto, welcome in. Thanks for coming in. C was the first language I learned like a decade ago. Nowadays, I recommend GitHub, Copilot, and Python, but C is a good place to start. Yeah, we already know Python and stuff. Pretty fluent in Python so far. We're just learning C so we can better understand Python and further progress as a computer scientist, wanting to really understand how the computer works and how our code actually interacts with those features, right? Cool. Um, so it was on the Unix operating system. Language is needed for the further development. 1970 was written and then wrote. Okay, standardization. C continues to evolve over the time. So the development of the U.S. standard for C began in 1983 under the auspices of the American National Standard Institute. So American National Standards Institute, right? After many revisions, the standard was complete in 1988 and formally approved in December 1989 as ANSI standard of this. In 1990, it was approved by the International Organization Standard. Okay. So then what is ANSI then? So it's a private nonprofit organization that develops and coordinates voluntary standards for products, services, and systems in the United States, including those related to computers and programming languages. Right, a private nonprofit organization in the United States. So then in computing, you'll often see ANSI, ANSI, used in contexts like ANSI C. This refers to the standardized version of the C programming language defined by ANSI in 1989, known as ANSI C or C89. It's ensured that C code could be compiled consistently across different systems rather than depending on vendor-specific versions. ANSI codes, these are specific escape sequences used to control text formatting in terminals. ANSI character sets. It refers to the standard character encoding used on Windows system, similar to ASCII but extended. Okay, so this is a U.S. group that standardized C in 1989, and then in 1990, the International Organization of Standardization took that standard and standardized it, calling it to be referred to as C89 or C90. Right. Okay, so the American National Standard Institute verified a standard for C in 1988. And then in 1989, no, sorry, in 1990, International Organization for Standard verified an international standard for C then, right? Yes, you've got it almost. Here's the precise timeline. In 1983 to 89, the ANSI X3J11 committee worked on. These are such like the most random names. Like they couldn't like they wanted to really make learning this stuff the hardest as possible. They couldn't have made it like a little bit more friendly. Committee worked on standardizing the C language, which at that point had many slightly different versions across systems. In 1989, ANSI officially adopted the ANSI C standard, formerly known as ANSI X3159, in 1989. In 1990, the International Organization for Standardization adopted the same standard with only minor editorial changes, calling it the ISO EIC. So, in short, ANSI C89 came first, and then ISO C90, which was the international standard version of the same thing. And then in C99, added some new types, so just new versions coming out then, basically. Yeah, it's to save some space. Hey, Andrew, how's it going? Hey, Centrino, how's it going? You low-key motivate me to study too? Awesome, dude. Yeah, so make sure you subscribe and join here. We stream almost every single day, learning computer science and programming from scratch, teaching ourselves. We are pretty fluent in Python, and we're starting to dive deeper into more systems languages and lower level languages, so we can interact with hardware and potentially do some more projects relating to computers on like a whole. So yeah, thanks so much for being here. I appreciate you guys being. My name is Michael. I'm 26 years old. I have a degree in human biology and a minor in chemistry, and I work as a formulation chemist for a biotech company. And I've been teaching myself how to code for a little over a year and a half now. Yeah. So, and then we have the international standard or international organization of standardization, right? And so this guy, so ISO, so I'll ask, what is ISO? It's a global, non-governmental organization that develops and publishes international standards across almost every industry. Right. Okay, so then what we're going to say is, so in, we're going to say 1980, let's go back up to our timeline here that we had earlier. 1983 to 1989, right, was the ANSI X3J11 committee worked on standardizing C language. Okay, I'll take that. I like that. Okay, and then we have another time frame of 1989 here. I know it's probably like super not relevant, but I want to know more about the language and like know more about computer history and science as in general. And chemistry and stuff, you learn about like the godfathers of chemistry and like the, all of these, different scientists that, and then genetic scientists and these different physicists and things like that. You learn about all these and you're actually quizzed on them in your, exams in college because it's pretty relevant information understanding kind of like the past of how these things were developed so you can kind of take their ideas and build off of them to know how their way of thinking. It's definitely a good thing to know about. So then ANSI officially adopted the ANSI C standard, this version officially called in C89, right? And then in 1990, the International Organization of Standardization adopted the same standard with minor edits and calling it C90. Perfect. So that is the timeline. We'll say C timeline. C standardization timeline. So caught up on some chats. No, not the best viewers. Hey Ray, how's it going? Hey Mom, I'm confused but interested. You just popped up on my recommended. Nice, dude. I'm glad YouTube is recommending us to people. Thanks so much for coming in. Yeah, we're learning C right now. Thanks so much for coming in. Cool. So the language underwent a few changes in 1995, described in Amendment 1. And then in 1999, there was a even more publication. So right, there's C99, which some compilers aren't all up to date yet, right? The language went underwent a few changes in 1995, known as Amendment 1. More significant changes occurred with the publication of the new standard, C99. The language described in the standard is commonly known as C99 and ISO C. Once described C are now ambiguous to the existence of the two standards. So then we'll say 1995. 1995 through 1999, right? And between these years, development and publication of this guy. Commonly known as C99, right? Yes, that's right. In 1995 to 1999, the IEC committee and the internet worked on, began updating the C90 standard to reflect newer programming practices and hardware capabilities. And it was published here. Okay, I like that. We'll take that a little bit better of a definition. Okay. Cool. Rizzy G says, you're learning C. That's awesome. Yes, we're diving into C, my boy. Rizzy, everybody seems to be loving that we're diving into C here. A lot of positive feedback on C. So people seem to be loving this. So yeah, we're almost to 3,400. Let's keep grinding here. We're almost at 14 subs away from 3,400. If you want to join us as we stream almost every day, learning computer science and programming, teaching ourselves from scratch, make sure you join along here. This is awesome. I have my notes going here. If you want access to them on my GitHub, you guys can find them linked down below as we're reading this book, C Programming: A Modern Approach, second edition by K.N. King. And I have a link to the book PDF in my Discord link down below. Okay, so then we have strengths and weaknesses of C here. So let's just quickly jot down, we'll go strengths, and then we'll do this, and then we'll go like this, and the weaknesses, like this. Okay, let's just jot down a couple here. Strength and we both stem from the language original use. Here's some philosophy. We'll go here, underline philosophy. Okay, and we'll say C is a low-level language. Okay, C is a small language. And C is a permissive language. Right? Strengths: efficiency, portability, power, flexibility, standard library, and integration with Unix. Okay. Weaknesses: C programs can be difficult to understand. Right? C programs can be difficult to modify. Oh, we're missing one here. C programs can be error prone. Okay. Nice. Okay, so let's do, let's add in like lint. So what is lint? Let's go back up here. A tool in C used to check for errors can subject a tool written for C in the a tool traditionally found in traditionally provided in Unix and can subject a program to a more extensive error analysis than most C compilers. If lint or a small program is available, it's a good idea to use it. Libraries, some tricks, cool. So lint here, we'll say, we'll do another thing, go splint, right? Splint, an enhanced version of lint known as splint, splint.org. Okay, known as Splint, including many Linux distributions can be downloaded for free at www.splint.org. Cool. So if we shift Command V to view this markdown, this is our notes for this section. Cool. History of C. C is a product of the Unix operating system. Unix is a multi-user, multitasking operating system. It developed in the 1960s and early 1970s by AT&T Bell Laboratories by Ken Thompson, Dennis Ritchie, and others. It uses pipes and shell scripts to perform complex tasks. It's written in C, makes it more portable. All devices and files are represented by a single tree-like directory structure. Access to files and processes controlled through users and group permissions. Sorry, I got the hiccups, guys. Then ANSI is American National Standard Institute, a private nonprofit organization that develops and coordinates voluntary efforts for products, services, and systems in the United States, including those related to computer programming languages. And then the ISO is an international standard of kind of the same thing. Then in 1983 to 89, the C language was standardized for Unix-based variants with ANSI C in 89. And then in 1995, or by the ISO in 1989. And then in 1999, the C99 variant was published with some new updates, right? Then we have some strengths and weaknesses for the overall kind of philosophies of C. Cool. So that was chapter one. That was really that was a lot, but it was very informative. I actually learned a lot more than I kind of like thought I was going to. Like, um, obviously we had some introduction to C in the past and things like that, but this was really helpful in just kind of getting actually like kind of like my feet wet and understanding what is C and how I can actually like interpret like from a history point of view, um, and what its purposes are and what it can be used for. So this was a great chapter actually for kind of warming things up and getting us going here. So I actually really enjoyed this one. If you guys like this stream, please leave a like on the stream, and if you guys could, it's completely free. If you guys could just hit a thumbs up for me, I will be uploading this back to the channel. I'll be chopping it up, kind of all of the pauses and the breaks for kind of a fluent audiobook reading of and follow along of the live stream for the reading of this entire book, like I've been doing for Introduction to Algorithms and many other books on the channel. So if you guys would like to go back and listen to this chapter, whether it be on like your daily commutes or while you're like, waiting for class or whatever, it's a great opportunity just to throw in some headphones and listen to me kind of read it back. And you can get some more kind of subliminal, subconscious kind of iteration over it going again. And that really helps with the studying and kind of hearing those topics again. So thank you guys so much for being here and hanging out with me for today. We streamed for an hour and 20 minutes on this Sunday, just a quick one, reading chapter 1 of K.N. King's C Programming, A Modern Approach, second edition. If you guys would like access to these notes you guys see on the left side of my screen, they are found on my GitHub link down below for the entire book that we're going to be reading here. And thank you guys so much for being here, and I appreciate you guys so much. I'll see you guys in the next one. Bye, guys.